Good morning, good evening, good afternoon to you all. My name is Gloria, and I am here with the Getcoin Events team. We're going to be going over how to develop a DApp, and it's going to be a diploma DApp. And it's going to be an example today. And so before we get started, just a little bit of housekeeping. This session's recorded, so I will upload this session to our Getcoin Media YouTube channel here later today, so you can rewatch it if you need to. Second of all, is if you have questions, you can drop them in the chat, and I'll try to answer whatever questions I can answer. If not, you can head over to Discord and reach out to Everett. He'll be the one who will be able to answer your questions. Last but not least, if you can say hi in the chat, that would be great. You can let us know what you're working on and where you're watching from. That's a great way for us to get to know a little bit more about y'all, but it's a good way for y'all to know a little bit more about each other. With that, I'm going to go ahead and start the example. And I'll go ahead and monitor the chat too if you have questions. But other than that, we should be able to get started. So here we go.
Okay, here we are. Welcome everybody to this new session. Today we're going to talk about how create a DApp in Algorand, how create our smart contract, and most important, how can we interact with our smart contract. So today we're going to go through the development of the smart contract. We're going to go through the logic of a DApp. We're going to go through how sign transaction, send transaction, and how receive and the return values. So, nice to meet you, everyone. My name is Ever Diaz. I'm Bilingual Developer Relation for Algorand Foundation. So, let's get started. Basically, this is the overview of the DApp we're going to build today. Okay, it's a diploma DApp. We're going to create an application that allows a registrar or a teacher to set new diplomas for their students. And after this, the student will be able to claim their diploma. So you can have your own diploma. You can claim it whenever you want, and you can have it as an standard asset that we have in Algorand. Okay, this is basically the whole overview for this DApp. Let's first refresh how smart contracts work in Algorand. Remember that we have two important pieces in the application in Algorand. We have the approval program and the clear program. Basically, the one you have to focus is the approval program. In this approval program is the whole logic of the application, the whole methods, the whole functions, the whole business logic that we're going to be executing. But we have also, with this application, a global state and a local state. Global state is basically the variables, the data that are available for the whole smart contract, for the whole application. Whenever you access, even if you are made an opt-in or not, you can access to this global state and see what's the variables around the whole application. But when you need a variable, a data, or some piece of information related with a specific user, you have to set a local state. So the local state is a set of data, a set of variables that are completely related and only related to one user or one account. So this is the difference between global and local state. But today we're going to be working a lot with the local state because, of course, you have one user and you have one diploma. So this diploma has to be completely related to one specific user. So we're going to be working a lot with the local state. Okay. So whenever we want to interact and want to work with this smart contract or this application, we don't have to make any application transaction or call application transaction, which is we're going to make it with the SDK. Okay. That's a general overview and refreshing of how smart contract or application are working in Algorand. And this is the DApp we're going to build today. We're going to use as a client our Algorand SDK in JavaScript in this case, okay? You can use Python SDK if you prefer, or maybe the Java SDK, the Go SDK, I don't know. There are many SDK that we have available for you in JavaScript, in Algorand. So it depends on what you like to code in, what's your preferred language. So you go, check the website, check the developer.algorand.org, and pick the SDK that you feel most comfortable and start coding. But in this session, we're gonna be using the JavaScript SDK. Okay, the JavaScript SDK the focus is to use it as a client. I mean, it will be the piece of our application or system that will communicate or interact or make the app calls to the smart contract. And the blockchain, we will have our smart contract that will be having the whole functions for register the diploma, for issuing the diploma, for setting the register, who is the register, who is going to be creating the diplomas. And we will be having different kind of user. We'll have a student user and we will having a registered user. Register, it could be the teacher, you can call it whatever, however you want. But basically it's a person or a user that is the only one allowed to register some diplomas for the other users, for the students in this case. And we will be having local state for all of these students because we need to save that diploma state on the relationship with the user, because that's what we're going to be using the local state. And in our local state, we're going to be saving only the address for the register, because the only thing we have to save in this case that will be available to the whole smart contract, the whole application, is who is the registrar, who is allowed to create these diplomas. Okay, this is basically the most important pieces of information about our architecture for this session. Now let's make how it works. Let's check how it works. How will be the steps for creating this smart contract, for working for this smart contract. First thing we're gonna make for this dApp working, or for the system flows working, is the user, the student, has to opt in the smart contract, because of course you're gonna be interacting with the smart contract to receive your NFT, to maybe modify your local state and anything. But whenever you need create local state, and whenever you need to work with the local state with a user in application, it's mandatory that you need to make an opt-in transaction with the user for creating this local state. If you never made this opt-in, you will never have a local state. So in this application will never work. Okay. First things first, opt-in for the student to the smart contract or application. The second step is the user, the registrar, will create a diploma in the student's local state. Basically, he will not be creating the diploma. He's going to be registering this student has a diploma to claim. It's like setting a variable or a flag that it says that the user is able to issue a diploma. Okay, it's just a piece of variable. Then the teacher or registrar will create an ASA, an algorithm standard asset, or you can say a token, NFT, whatever you want, depending on how you create the metadata. We create an ASA of the diploma because in the second step, you are setting just the variable that it says that this student has a diploma to claim. In the third step, you will create the diploma. And for the first step, the registrar will change again the local state of the user. But what you're going to be changing? In the second step, we will be changing only the data that it says that the student has a diploma to be claimed. At the fourth step, we're going to put which is the ASA ID that represents the diploma that the user, the student, has to claim. Because, of course, you know that the user has a diploma to claim, but you have to know which diploma is claimable for him. Because remember, it's a unique diploma for each of the students. Then we have to make that the student made an opt-in to the ASA, to the algorithm standard asset, because of course, if you don't make an opt-in, you will never be able to receive the asset, which is the representation of the diploma. The sixth step is claim the asset, or receive the NFT, receive the token, receive the asset that is the diploma. And for the final, he has to clear his local state, which means whenever you receive the diploma, okay, you already received, so you have to delete the piece of data that in the smart contract that it says you have a diploma available to be claimed. So that's the whole steps for the application. It's a very simple application, but the idea is that this will be, maybe if this is your first encounter with algorithm development, this will serve you to start to understand what's the flow, understand how the SDK working. But remember, this is not the last workshop. We have many other workshops upcoming, and you will be exploring a lot of tools that are different to this, and a lot of tools that will help you to complement a lot the knowledge about how creating application in algorithm. Okay, let's create the code. This is the repository URL. You can download it, you can clone it, but just notice that it's not the master tree. You have to go to the SDK that is a dash version 3 to download this code. Okay, let's take a look on this and how it works. First thing first, we have to create our virtual environment in PyTeal. So let's create this. Let's put here diploma deep dev. Okay, sorry, this was Python 3. Okay, now let's activate the virtual environment. Now we have activated, we have to install the requirements that comes with the repository. Basically, what are the requirements? Basically, PyTeal and the other things that the Python environment needs for creating this Python project. Okay, let's wait for a second that the pip finish for installing the whole requirements. Okay, there we are. It's done. Now let's go to the smart contract and let's take a look what it contains. Is, as I mentioned, the code is very simple. The logic is very simple. The idea for this is that you start to explore how it works, explore how the interaction. Okay, you can add whatever you want. I mean, you will see here a total base or template for creating a maybe a more complex smart contract or more complex application. It depends on your use case or your business logic. Okay. So basically what we're doing here is declaring the local and global variables. In this case, we'll be having one global variable and two local variables. This will serve for the local state. This will serve for the global state of the application. What's this? Basically, the global state is keeping the register, is saving the address of who is the user, who's the account that is allowed to create or register diplomas, because it's only one account allowed to create. Then we have a local state or a local variable that is a diploma. Basically, it's the information for the diploma, maybe the title, maybe the metadata, maybe anything, whatever you want, any identifier. And then we have the ASA diploma. The ASA, this is basically, which is the ASA ID, the asset ID for the diploma that is already minted. Because remember, after you register, the student will have to claim this diploma to use it. Okay, then we have the approval program, the clear program. Let's go first with the clear program. The clear program is basically a piece of data that allows to eliminate, it's like eliminating the complete relation with the user. So basically, you don't have to make much thing in the clear program unless you need a complete detailed logic there. You just can put only return int one, and that's enough for this. What the approval program is the piece of code that is completely related to your business logic. Here will remain the complete functions, methods, and all the steps for working on your application. Okay. First thing is check this. What is the program and how it's built? You will see a conditional for PyTeal that basically it will work. It will control in the flow of the application, and we will have like 5 different variations. First one is the init contract. Remember that an application is never deployed until it has an app ID. But if it's not deployed, how can you recognize that it's not deployed yet? Because the app ID will be 0. So what it's doing here is comparing the application ID to 0. If it's true, it's going to execute the init contract piece of code. And let's see what is init contract. Init contract basically is a sequential of steps that is saying app global path, global register, transaction center. What does it mean? Because this means that the application is going to be saving in a global variable called global register the value of the transaction center. It means that whenever you make a deployment of this application, of this smart contract, the person, the user that is sending the application, that is sending the transaction for deploying this smart contract, his address will be saved as a global register. It means the person that created the smart contract will be the register for creating the diplomas. This could be changed. If you wish, you can add another function that maybe changes the register. I haven't put here, but you're completely free to put in and add more logic for this smart contract or for this application. Okay. After that, we have the contract completely initialized and everything is okay. Maybe it will be deployed. You will have the app ID for this, and that's cool. Then we're having another step that it says that allows to make the opt-in. If you don't use this, you will never be able to create an opt-in or make an opt-in transaction, which is And in our case, we are using local state, so this is completely required. The close out is basically, it's like opt out. It's like deleting our local state and eliminating the relation with the smart contract with the user. So you don't have to define everything. You don't have to define anything here. At least that you have a complete special or personalized logic for the opt-in or for the close out. In our case, it's not required, so we just put a return into one. That's enough. And then we have two different execution of transaction. If we receive in the arguments of the transaction a string that it says register diploma, we will execute the register diploma function in our smart contract, which is this. Basically, a sequential of first, it will assert this piece of code that is basically comparing if the sender, basically the wallet or the account that is executing this application code is the same that is registered on the global register, then we'll allow it to execute. Because why? Remember that register diploma is only available for one account, for the registered user. So we have to check, we have to compare that this account is equal to the one that has been registered when we initialize the contract. Okay. Once we already review and check this, we have to make a local put. The local put basically inserts a value in the local state in a specific variable. In this case, what it says, app local put, which account, diploma receiver, and what is the diploma receiver is the transaction that accounts. What is this transaction that accounts? Whenever you make a transaction call, you can define your arguments, okay? But you also can put an array of accounts because maybe you will need, in some cases, to send 3 different accounts for the application working. It depends on your logic. Here I'm sending just one account. Okay, so I'm using here the accounts in the slot 1. The slot 0 is basically reserved for the sender, but in the slot 1. And what I'm doing here is putting, okay, I'm sending this transaction with the account of the diploma receiver or maybe the student. So I'm creating a local state with the student indicating the address. I'm using the variable local diploma and I'm putting the value of main data. What is main data is basically the string or the JSON or whatever you want that you are sending on the arguments of the application call. Okay? And basically return. That's everything with the register diploma. What it's doing here is creating the local state for a user with a value that you are sending. Very easy. What is the other operation? Set ASA. It's basically the same, but instead of registering the local diploma variable, you will be setting the local ASA diploma variable. Because here you are putting the title maybe of the diploma. Maybe this is a diploma for your Blockchain Developer 101 course completion. Okay, that's the title. But you will need to save also the asset ID of the token or NFT that the student will claim. So that's where we put in 2 different operations, 2 different steps. And that's it. Basically, that's the smart contract. As I mentioned at the start of this session, this is very easy. It's very simple. It's just a way for now how this works. I know that in the previous session you already have an explanation of what are the operation in PyTeal, what are the type of data in PyTeal, how PyTeal works and everything. So basically, I'm putting here the full logic of this application. And you will say, okay, Ever, this is so simple, and yeah, it's very, very simple. But the question is, how do I interact with this? How do I deploy this smart contract on the network? How do I make the transaction, the application call transaction? How do I set the register? How do I put this NFT? How do I do everything here? Okay, we're going to start with this part of the interaction. First thing, deployment. If you go to the README in this repository, you will see the whole steps and the commands for creating whatever I'm doing here. Okay. First thing you have to do for start to communicating with your sandbox. I will exit my sandbox. So I have one here. If you are taking the whole session in these greenhouse hacks workshops, you will notice that we had a first video the last week about how to set your development environment. Okay, in this video we talk about how to install Docker, how to install a sandbox, and maybe I don't know, maybe there was an extra step that is taking these volumes on your Docker Compose. What this do? Basically, this piece of code allow to the sandbox to access your files on your computer because we need to deploy one smart contract on the network. Okay, but you have two ways: or you copy and paste the complete code in TEAL, or you just send a file with the whole smart contract in TEAL. Easiest way is to just send the file with the TEAL contract. So what you will do is copy this piece of code. You will go to your sandbox folder, and you will find this Docker Compose YML. You go just below ports, and you paste it right there. What this does, oh, of course, you would have to modify specifically what's your source for your files right now, because I have a whole folder for my whole application, my whole codes, but you have to specify where are your code, where are you working right now, where is based your folder for your smart contract and everything. So you put it here, and that's it. That's the first things you have to do for at the sandbox access for your files in your computer. Okay, that's easy. Once I do that, I go to the sandbox and start to enter the sandbox. If you haven't launched your sandbox, you have to do this first. Sandbox app. This basically create the sandbox or launch the sandbox so you can enter. I already have launched and already is working for me. So you can see here that we have the sandbox over here, so it's no problem at all. But well, if you don't have it already launched, you have to do it. I already have it, so I will go enter my sandbox as well. Sandbox enter algo D. Algo D is the algo diamond. It's basically the piece of code or the execution of the virtual machine for algorithm. Inside the algo D, you will be able to create accounts. You will be able to see your accounts. You will be able to send some transaction and anything. If you go to documentation, you can check the docs, CLI tools, and you will see that these whole CLI tools are available in the algo team. Example, Go let you work with the accounts, with the application, with the assets, make transaction, may manage keys and wallets. It has a lot of things that you can use on your sandbox. That's for your homework. You can explore and you can start to play with this with no problem. Remember that this is a sandbox, this is a private network, it's a local network. Whatever you do here, it doesn't cost any money, so you can play in whatever you need. Okay. Now we have the sandbox open and we are inside the Algo D diamond. We have to deploy the smart contract to the network. How we do that? We need the TEAL files. But what is the TEAL files? We just made a smart contract in PyTeal, not in TEAL. So we have to compile the PyTeal to TEAL. How we do that? There's this piece of code that I already do this for you. Basically, you have the compile TEAL function, and you pass it the approval in the clear program, and that's everything. And it will generate a TEAL file for the approval and a TEAL file for the clear. So let's see. As you can see here right now, we don't have any TEAL over here. This is the card. This is the folder. So we make this and basically execute the contract, and it will generate, as you can see, the clear program that is basically empty, and the approval program, which is our logic for the application. There is basically the register that we set, the diploma function that we set, and everything that we will be setting in the PyTeal case. Okay, now we have this, we have the TEAL, we already compiled our PyTeal TEAL, we have the Algo D open, we have the sandbox running. Let's make the deployment. How do you do deployment? With this right here. Basically, is an execution of the command line tool for the Go app. You can go here and you will find create. Go upgrade is the piece of code that we're going to use. You have here all the options for executing, all the flags for executing this command line. But I will just use the basically for creating this smart code. Okay, first I will check my accounts, and I will have to select one of those. I will select this one here, this first, the FOO. Just for easiness purposes, I will create a new variable that will be the teacher, and I will put this address. If you wanna test that is already saved, you can do this echo teacher, and you will see this. So the teacher will be the person that will be the register, and also will be the person that is creating the diplomas or selling the diplomas, like I said. Okay, now let's go. Go lab, create. We set the creator flag, and we put here teacher, which is the address that we already defined. And we are going to point where is the approval program. Remember that in my case, in my Docker Compose, I put this folder or this access for data. But inside my folder, I have workshops. Inside here, I have the folder PyTeal. And here I have the approval teal. Now you have to set the clear program. And basically it's the same. Data, workshops, in hacks, PyTeal, and clear teal. Now, what is next? You have to define what is your variables structure. It means how many ints and byte slices or strings, how you want to call it, byte slices you have in your global and in your local state. Let's go back to the contract, and we define one variable for the global state that is byte slices. It's a byte, and we set two local variables that also are bytes. It's not numbers. So, okay, we have 0 global ints and 1 global byte slice. We have two local byte slices and 0 local ints. Then let's put this on our code. Global int 0, global byte slices 1, local int 0, local byte slices 2. We just put enter, and it starts to deploy. We expect for the block to be transaction, and that's okay. And he says that our application is being created with an index of 174. I will save this over here, app ID, because it will be really useful in a while. How can you prove this? There is an application that is called adaptflow.org. You can access here, explore.adaptflow.org, and you will have the chance to explore not only the algorithm, the algorithm testnet, betanet, and mainnet, because the official or the most used explorer for algorithm is Algo Explorer. But here you can only see the mainnet, the testnet, and betanet. The difference with the Adaptflow is helpful for developer because we can access also to the sandbox, to our private network. So over in the sandbox, you go settings, you pick sandbox, you put save, and that's it. And you can access your local network. Because, of course, the Algo Explorer will not be able to access your local network because it's just focused on testnet and mainnet. Okay, let's go. Now, we created this. How can you prove that it's created? We go to transaction. We go to the last transaction made, and here it is, the application 174. This is the ID for the transaction. You can enter here. You can see the TIL for the program that is being uploaded. You can see the TIL for the clear program. You can see the global data also that we created a register with the values FOO. And what is the FOO? As I mentioned, the FOO is the teacher account that we define. Basically, the person that deployed the smart contract is also the register in our logic. Why? Because we set this init contract function that basically takes within the contract. Oh, it's here. That basically takes who is the sender and set it as a register. You can change it if you want, but that's the most easy way that I found. Okay. Now we have this. We already deployed. We can start with the application workflow. What's the first thing you have to do? Opt-in. The student has to opt in. Let's pick a new account that will be the student. We have different accounts. I will use this. 4EI. I'll put this like a student and the same. Let's verify that is set. Okay, that's good. Okay, now I have the student. I have a teacher and I have a student. They both have a lot of microalgos for working. First thing, you have to opt in. Okay, I can do this. Well, opt in, app ID 174, I guess it was, from the account. What's on the account student? I could do this, of course, but this is basically working with the command line tool. But the idea is that you're working with the SDK or with your application, with your front-end application. So we're going to do every step here, all of these 7 steps, we're going to do it with the SDK. And if you want, you can create a React application, an Angular, Vue, whatever you want in the front end, and using the SDK for make the exact same application calls that we're going to make here. So let's go to the part of the client. Okay, we have the client here, and we have these files. Let's explore each of those. First one is the connection. Connection is basically the implementation of the client for the algo and for the indexer. Why the indexer? Because the indexer will help us to check the local state of a user. Because remember, the user will be able to claim an asset. But we have to review and verify that this user, this student, has a local state that is saying that you have an asset to be claimed. Why do we review that with index? Index is basically the part of the application that will help us to review this local state. In the algo decline is basically the part of the code that will help to execute the whole transaction, the whole execution. Okay. For each of those, you will need a token, a host, and a port. This is basically standard. You just can copy and paste because if you're in the local, this is the standard for the local and the private network. And this is the way how we implement and we instantiate all of them, the algo decline and the index decline. Basically, if you wanna, you can go to the algo JavaScript documentation for the SDK, and you will find everything that I'm doing here is already documented over here. So if you want, you can go here. New algo SDK, algo db2 is basically the execution, the class, and you can make the instantiation or with the constructor. And that's it. That's basically what I'm doing here. Just instantiating the client for the algo D and for the index. That's all we do with the connection, and we're exporting it because we're gonna use these clients in the other piece of code. Then what do we have? The data. Inside this, we're gonna put the app ID. You can use a .env if you want or whatever you want. Remember one thing: whenever you are creating a smart contract, never, ever put your mnemonic phrase or sensible data on the front. Put it on the back end, maybe some way of being encrypted, I don't know, but never put it in the front end, okay? I'm doing this because only for teaching and showing purpose. You never do exactly what I'm doing here, at least this little piece of code. Okay, what was our app ID? It was 174. Okay, let's put it here. App ID 174. Good. And what else do I need? I need the mnemonic phrase because I have to convert that mnemonic phrase to a secret key to be working on the application. Why? Because whenever I make an application call, I have to sign the application. This signing can be done with a wallet application. Maybe you know MyAlgo, maybe Pera Wallet. You can make it over this application that already manages all this transaction signing. But in our case, we're just using the SDK. So you need the secret key. You need the mnemonic phrase to make the signing of all transaction. How do I get this mnemonic phrase from my accounts? Oh, this is in the README. You can check also if you want. This is here. So basically, I will say I want to get the mnemonic phrase from my teacher. Gold account, export account, and I put here teacher. This will give me my mnemonic phrase, and I will paste it in the data.ts. Okay, there we are. And now let's get the mnemonic for the student. Same thing for a student. Okay, it's cool. We have it here. Copy, paste, and that's it. Okay, now you have all set it for start working with your client for the application and start interacting. Remember, we have connection here, we have data here. It's all exported because it's all will be accessible for the other part of the client. The client basically is this app that TypeScript. Is everything commented, of course, because we're going to be executing each of them in order, so we can take a look what happened inside. We're basically making the imports or for everything that we need that is in the other part of the code. If you see these methods, is basically a file where I'm putting each of one of the methods that we will be gonna use. The opt-in application, the register diploma, basically the whole steps we have right here. Remember, it's 7 steps. So we have here 7, 8, 9 steps difference. No, 8 steps. Why is 8 here? Because I'm using also a conditional, this one here. So it's like 7 steps and 1 condition. And conditional is only verifying that the student has a diploma to claim. Okay, but it's just 7 steps. Let's go to the application.TypeScript. What's the first thing we have to do? Opt-in. Remember? Let's go to these steps and we have this opt-in. Okay. How is opt-in working? How is built on? Basically, it's this. Remember, this is the typing for the type for TypeScript. So basically, it's the type of variable we need for calling this function. We have to take the suggested params. This is basically if you don't want to mess with the fee, with the flat fee, and other variables. I only recommend that you use suggested param for each transaction. It will save you a lot of time. At least that you need to put something like different fees or different kind of information for your transaction. But if not, you don't complicate your life. Then you have, for every kind of step, we're gonna make almost the same. Create a transaction, sign the transaction, and send the transaction. It's just 3 steps for each of them. Okay. Let's go with this. This is an opt-in transaction. So we're making algo SDK that make application opt-in transaction from opt-in. How do you know this is working? How do you know how this works? Go to documentation, go here, and check. Okay, this is the make application opt-in transaction from object function, and you have all these parameters or arguments that you can use. For apps, you can also put different a node or anything that you could need from this specification for the function. I'm putting here who is the address that will be making the opt-in, which application I'm doing with the app index. I don't know why I put this or delete, and the suggested param that we already defined over here. It's just 2 main variables. Then we have to make the transaction that we have, that is TXN. We're gonna make a sign. Who is signing this transaction? The student S key. What is the student S key? Okay, let's take a look on this. Let's go to data, Omega console log, so you can check this. Remember that we put in the mnemonic phrase here, and we're saying, please, algo SDK, take the mnemonic phrase and create a secret key. What is the secret key? Let's take a look. Register. I will put here. No, I have to go to the client and execute npx ts node, and it will be the data. Okay, this is the secret key. This is not a secret key. It's basically the whole object for the account. And what is here? We can see the address and we can see the secret key. The secret key is basically a UN8 array that will serve for signing transaction. This is the piece of the code that signs the whole transaction. That's why whenever I say in the code app.ts, not in the code methods, transaction, please be signed by the student SK, it will be signed by this piece of code, by this UN8 array. Okay, that's basically what we're doing. Then we're gonna make the execution of the transaction. We're gonna put in this object that will receive the result of the transaction, and we execute the algo declines and raw transaction with the signed transaction already, and do what is for executing. And we will receive the transaction ID. We can have a lot of information from the transaction executed, but you only gonna be putting the transaction ID over here. So that's basically what we're doing. An opt-in. This is basically for the user can interact with the smart contract and he can have a local state. How can you verify this will be working? First, let's go to README and you can see that there is a command number here that we will do for start to checking that. Go up, read. Basically, we're going to read the local state of an account with a related application from student app ID 174. Guest format is just for be like more readable. We put it here and it says the account 4EII hasn't opted to the application. Okay. Then let's send the transaction. Remember in the methods TS, I'm just declaring the function and I'm exporting to be used on the app TS. Okay, the app TS is the one that is executing out. So the only thing that I have uncommented is this opt-in application. So let's execute it. It's executing and that's it. That was very easy. Let's take a look again in our sandbox, the local state, and it says, let me see. It doesn't say anything. It says an empty object because now there's a local state existing with this account. Of course, it's empty because we haven't said anything, but it exists. And how we see this transaction and what it means, let's go to the dApp flow. This is our Explorer. And let's look for this. Now, can we see here? The sender, which is the account we're going to opt-in, to the application call, what kind of application they opt-in. That's everything. Okay, cool. Now we have the first step already done. Let's see the second step. Register diploma in student local state. Okay, now the register, which is the teacher, which is the person that deployed the smart contract, will have to create a data inside the local state of the student. So let's go to check this part of the code. Recommend this and we go this. Register diploma to local state, the function. Let's go to the methods so we can check how is composed this part of the code. It's basically the same. You can see the user params, and we're putting here an app args because remember we have the contract.py. We have this function, but how do we know how the smart contract knows which function execute? Because you will receive inside your arguments, you will receive a byte slice that it says in a string register low dash or underscore diploma. How do I send this in an application call? There is a thing that you have taken in mind whenever you interact with the smart contracts in Algorand, which is the encoding. You cannot send just raw strings or raw ints to Algorand. You have to make some formatting or some modification. Okay, in this case, I cannot send the string. I have to make a conversion. So what I'm doing here, okay, I'm putting the args. What do I need to send? I need to send first. I need to send in the args, in the first part of the arg, I have to send this string, but will be converted to uint8 array, which is the most used over here for Algorand. Okay. So that's the first argument that I'm sending in this application, in this transaction call. The second is diploma. What is this diploma? It's another string. And what is this? Let's take on the contract. Remember, in this case, we had register diploma. We have the main data. The main data is basically the string that you will put inside the variable of local diploma. Which could be the title, which could be the description, a JSON for the metadata, I don't know, depends on you. Okay, but we're creating a transaction with an argument in the slot 0 of this string, which is the controller for knowing which function will be executing. And the second argument is basically the data or the value that will be put on the local state. Okay. So we have this, we create the app args object, and then we create the transaction. Let's take a look on the documentation again. Let me check. We find this, and what it says, we have a different kind of parameters. but it says the app args, it has to be an array for uint8 array. That's the reason why we put this transformation, this conversion. If we put only something like an array of strings, it will fail completely. What else we need? We need this is optional. This is also optional. An account strings array. This is mandatory. So you can check there what is needed for executing this transaction, and you can just put it. So I'm putting the app args, the app index, which is what is the smart contract I'm interacting. Who is interacting? The registrar, of course, which is the teacher. Suggested parents. In every case, we're using the suggested parents. OnComplete. What is OnComplete? Let's take a look at the documentation. OnComplete is another parameter that is mandatory. But what is this, and how do I know what I'm putting 0, what I'm not putting 1 or 20 or 50? I don't know. You go to this guide and you can see, okay, whenever this is basically, as it says, this parameter indicates what you want to do, what you want the application do whenever it finishes the execution. What you want to do? Maybe you want to clear your local state, okay, you can do it. Maybe you want to close out the application. Maybe I make a call and then I want to close out, clear my local state, could be. Maybe you want to delete the application. Maybe you want to have a smart contract whenever you make an execution and just delete the whole application, it could be. Or maybe you don't want to do anything. That's my case. I don't want to do anything. I just want to execute the register for the local state and don't do anything additional, because I'm going to do another different steps. Well, you can see the guide here and you can choose whatever you need from your use case. Okay. So that's right. And then we're passing also an array of accounts. Whenever you need to interact with any other account in an application call on your smart contract, you need to send an accounts array. That's the way you get the account for interact. I'm sending an array of account with just one account, which is the student account, the address. So that's the way I build my transaction call. And whenever I send this, with these arguments, we will now be executing. Receiving the transaction will verify that the smart contract is already initialized because the app ID is not 0. We will see that this is not an opt-in or closed out application, and we'll compare the first argument with this one here. We'll execute this piece of code. We will check if the sender is the registrar or not, because it's the only one that can register. We will put in the local state of one account, which is diploma receiver, that is the account from the accounts array. We'll put this variable here. We want to insert this value here, the main data, who is that we're receiving from the call. So that's it. And okay, now we made the transaction. We build the transaction object. We have to do the same everywhere. Sign the transaction, execute the raw transaction, wait for confirmation, and execute. So let's see. Let's go to the app. Just get this uncommanded. Execute. And we'll check the local state again. Okay, it says that it's already on. I have to comment this because I guess I put some, I put this concept. Okay, cool. Let's go here. Now, let's do the same. Let's go to the sandbox and let's check the local state for the account. Okay, now we have an empty object. We have here that is a diploma. There's a type of data 1 by slices, and the value is diploma course new. This is the title. You can put here maybe a whole JSON. Maybe you can put here, I don't know, a hash for a JSON for your metadata. You put in there your image, your description. I don't know, depending on what you're following. Maybe you can follow an arc for this standard of tokens, depending on what you need. But we have right now a local state that is not empty. So this is working. We have now the second step already done. The register has created a local state where it says you have a diploma to be claimed. What we need to do next, create an asset that represents the diploma. I'm just creating an asset, a raw asset. You can change this and create, you can create an NFT if you want, or a different kind of tokens. It depends on your taste. Okay, let's comment this and let's do the third steps. Create ASA and keep. Let's go to the methods and see what is this doing. Same thing, suggested params, and we're instantiating a transaction, which is called make asset create transaction with suggested params from object. We can go to documentation again, and we can check this one here. And it says everything you need. This is basically for creating an asset. It doesn't specify if it's a NFT or a token or a non or a semi-fungible token. It depends. It depends on what you define here. If you need an NFT, we just put it the decimal on 0 and put the supply on 1. Okay. So we need to put every mandatory arguments, parameters inside the function, inside the transaction. So I'm putting who is creating the register. I'm putting a note here for the transaction, which is only saying the student from a generation, a total of 1 token, 1 asset, 0 decimal, because this will be like a unique diploma. Default frozen, this won't be frozen. The manager, reserve, freeze, callback, all be. These are a special kind of accounts. Depending on this, you can have the ability to update the token, to maybe send this token to a reserve account. Maybe you can freeze. You can specify here who is the address that will be available to freeze token and who's the address will be available to clawback. Clawback is a very specific, very special feature in Algorand that will allow you to retrieve a token whoever is owning and take that token out of his wallet and save it back. Here's many use cases, but remember this is optional. It depends on the design of on the system. Now we put the unit name and we have the asset name. The asset name is basically a composition of diploma 4 and the 6 first characters of the address account for the student. Okay. And so just params. We sign the transaction again, execute the transaction. Let's wait for confirmation. And we were putting okay. We're saving the confirmation after for using the asset ID. The asset ID is inside this confirmation execution. Okay, so let's go to the app and let's execute it. Clear this and execute the creating of the asset. Okay, now it says the asset ID is being 178. Let's go to Explorer and you can see assets here has been created 178. We can check for the last transaction made here. And there we have it. There it is. One DPLM, fall frozen. And what it says here? This is a diploma for this account. This is the way we can identify who is a diploma for everyone because each diploma is unique for every student. So that's cool. We have it here. And who created this is already here, and he is the person that has this diploma, 178. Okay, right now the register is the person that has a diploma. Now let's see. With that, we have made the third step. Let's go to the fourth. What's the fourth step? Change the student. Okay, we now have the asset ID. Now we have to indicate on the local state, we have already, okay, we have this in the local state of the student that it says you have a diploma to be claimable. Okay, this is the title, but we have to know which is the asset ID of that diploma to be sent. So because the student have to claim an asset and receive an asset representing the diploma. So we have to specify which is the asset ID. What we do here is copy this 178 asset ID, we put it in the data, and we'll put it here. Save it here, and let's go to the next step. Next step will be modify the local state and add this information for the local state, the asset ID. This is basically we're gonna send a transaction with this string on the argument 0. We say set ASA, we'll execute this function over here. We'll review that is the register the only one that can change this. And we'll put a local state variable for the account that we're sending in this variable with this value, which is the main data. It's basically almost similar to the one the last we made. Set as a local state. Same thing, suggest the params, create the app args with the conversion to UNIT write, we create a transaction, Also, again, you can go to documentation and you can check what's inside and what's needed, what are parameters, what are optionals and mandatory for this execution. Make application call, transaction guys made are the same that we made on the first. App args, app index, what is the application I'm pointing, which user is doing this, use the params on complete zero because we don't want to this execute anything after the running of this calling, and array account because we're going to be interacting with one student because we have to modify this local state. Same thing, we sign it, we send it, we await for confirmation, we console log the transaction. Let's go to the app. Remember that we have already, in our local state, we have only the diploma course new, because this is just one thing that we've been registered by the teacher in this student. Now let's wait here, and that's okay. Oh, and of course, you can go here on the Explorer, and you can check, and whenever you're interacting with a smart contract, you will see in the Explorer that this is basically a knob. On completion is an application that of the call type. Okay, you will see here in encoding the application args. You will see the array of accounts that have been sent, and you will see here the local state that has been modified. An action set on the diploma ASA variable with this value. And there's also information there, additional information. So let's check now the local state of the user. Okay, now we have not only the diploma title, we also have the diploma asset, which is the ID of the asset that we will retrieve for this student. Okay, cool. What's the next step? Let's go on our design. 5-step, opt-in to the asset. Okay, the student have to opt into the asset, which is already here. We're gonna be uncommenting this, and I will explain what is inside here. Before doing this, I'm making a verification if this user has a diploma to claim. Okay, if we go to the methods, we have a helper function that only use the indexer. Now we use the indexer, not the algo SDK, not the algo client. It's the indexer client. So just the pattern and everything, and I'm not using this. I'm not going to have this, nor this. Okay, we have the application ID, which is the app ID, received from the function. We don't need this almost because we can put it straight here. Sorry, guys, I'm just making some enhancements on the go. To the pedal to the metal. Okay, we have it. Cons account application, which is the thing that will here we will receive the local state of this account related with this application ID. Basically, it says lookup account, and we have the student address. We're looking for an account that will be the student address and the relationship with this application ID. We're creating a variable that is false. At least you have a local state. If you have a local state with this query, we will set this to true. Basically, we're having on this object, we're looking for this app's local state. If this has more than 0, it means has at least one object, which could be this or which could be this. It means that this user have a diploma to be claimed. So we set this variable to true. We console everything. This is just for a helper string, and we return this boolean value. Okay, let's execute it. Right now, we just have an if, a void if, an empty if that will say if you have a diploma. Okay, it says student has a diploma. That's cool, awesome. So let's go with the next step, which was opt-in to the asset. Let's uncomment this. Let's go to the methods, close this, and open opt-in diploma. One important thing is whenever you want to opt-in to an asset, this is quite different for application opt-in. For the application opt-in is an opt-in transaction. For asset opt-in is a transfer transaction. You have to make a transfer from you for you with an amount of 0. That's how asset opt-in works in Algorand. So we create a transaction from a student address to a student address with the amount of 0 and with this asset index, which is basically, we were this 178, 174. No, 178, I guess it was the asset ID. Yeah, right, 178. Let's take a look. Thanks God we have this Explorer. 178, cool. Awesome, so signed it, executed, and let's see. Okay, let's go. First, let's see over here, this account. This one here. Let's see which asset is obtained. This is being obtained to another asset. This is from a previous testing that I was doing, 163. So let's make this operation, and we will see that now in the Explorer, okay, I think it's already updating. Yeah. Okay, this thing is opting already. Yeah, this is good. It just take a while for an update. So it says you have another asset where you opted in 178, but you have 0. But we now know that this account is being opted into the asset. Awesome. So we made the 5 step. Let's go to the 6th. Climb the asset. Okay, let's go to the app, comment this, and uncomment this. Send diploma. Who has the diploma has it the registrar or the teacher. Now we have to make the smart contract or this application send the diploma to the user, to the student. How we do it with a transaction again, but in this case won't be 0, won't be 1. Because who has this NFT? Let's see, 178. We can see the creator, his asset 178. We know that he has 1 of this asset. Now, and we want this asset will be for this account. Basically, from the register to who, to the student, amount 1, the asset index, you have to specify this asset index. And where is this specified? Remember that you have data, that TypeScript, where you have this, and we have the app that is importing that part of data, right here, the ASID. And that ASID is going to be inside of the parameter of the function, which is being used over here, ASID. Okay, just for notice that. And the same with all the variables we're using over here. Okay, we have this transaction built, we sign it, we send it, we wait for confirmation, and check the transaction ID. Remember that in Algorand is basically almost the same about transaction. Build transaction, sign transaction, send transaction, and wait for confirmation. Okay, let's see. Awesome. Then if we update, reload this, we now can see that our student has his diploma, has received his diploma. So cool, we already made application. But let's wait a minute. How did I receive this? I mean, if we run this again, maybe the application will tell us that this student still has some diploma to be claimed, and maybe will generate any kind of error, because if we execute this again, it will say the student has a diploma, but the student already claimed his diploma and already has his diploma, so he doesn't have to be able to claim again. How do we solve this? Well, there are many ways, and this is just the most easy way, but there's a homework for you, so you have to enhance this over here, okay? The last method is the clear local state. Remember, right now our user has this local state. We can execute a transaction that is make application clear state from student, which relation of this app, Judith Barra, sign is send it, wait for confirmation, and execute it. With this, we're going to be deleting this local state. So let's see. And making a close out from the application. It's executing. Just wait for a second. Let's go to the Explorer. Let's see the transactions. The last transaction, this one here. Clear. So basically, it's being a transaction that after being finished, is making a clear transaction for executing everything. Now, if we go to the local state of this student, we can see now that this student has not opted into the application. It means that this student has deleted his local state, has making a closeout, is not relating again with the smart contract. But this student has his asset with his diploma. So cheers, congratulations. If you've been following everything and you have the code downloading on your computer, this is basically how you create a complete app for in Algorand. This is, as I mentioned, this is a very simple example of working. Because of course, I don't. If I want to go deeper, we can take maybe the whole day. We can talk the whole day for how to increment more functions and go more deeply in this logic. There are many things that you can add. Maybe you want to add a revoking function. Maybe you want to add, I don't know, the NFT go to a smart contract and know for the registrar. I don't know. There are many ways. There's also you can create a front end where the front end you sign the transaction and you receive the NFT. There are many things that you can enhance. This is only a base example so you can understand how transactions work, how SDK works, how Algorand works, and how you can create or how can you make an interaction here. So congratulations, you already made this little dApp in Algorand that allows to create diploma, register diploma, and claim diplomas. So awesome, congratulations for that. Let's take a final look on this, okay? We've been coding this, okay? We're done with the code. Now here's your homework that I mentioned. First thing, Algorand has something called atomic transaction, which is basically when you group different transactions from being executed at the same time. Why we're doing this? Why we have this? Because sometimes in some logics, you need to make 3 things or 4 things at the same time because are completely related, because are completely necessary. As example, maybe you can do you can make the modification of the local state of the diploma title and the SID at the same time. And maybe you can have this over here that can be nested or can be completely related. I don't know. You can make a dependency between these 3 execution as example. Or maybe you can do something like the opt-in. I don't know. You try to look at this. I recommended doing the 2 and 3 and 4, or maybe you can find another set of transactions that can be made at the same time. And your first homework is create an atomic transaction for this. Okay. Your second homework is we created an asset, okay, but as you can see, this asset is completely empty. Right here. It's empty. It doesn't have any metadata hash. So your homework is to add a metadata hash, maybe with a image description or something. You have to go to the websites of Algorand arcs, and you can pick which is the best arc for this kind of scenario. We have an arc for fungible, not fungible, for NFT, for digital media. You can go here and you can check how is described the JSON metadata. Okay, so take a look on this and try to create a token or an asset that is following any arc for your metadata. And for last, remember that in the last step, we're deleting the local state. Your homework is don't delete it. Just add a flag and modify the whole application because, of course, maybe the student claimed his diploma, but how do I know that he already claimed? Because we are deleting the local state. How do I know that you already claimed? And as a teacher, maybe I don't do again the process for giving a diploma. So don't delete the local state. Just add in some flag or some way or some method or some logic for the teacher can track that a student has already claimed his diploma and doesn't have to receive anymore your diploma. So you don't do things again. So that's your homework. It's fairly simple. You can reach the Debrel team for any kind of help that you need. Remember that you have the mail that is debrel@algorand.foundation for any kind of question that you could have, or you can go to Discord and make any question that you could have. What else can be modified? In this example, we just made a raw PyTeal application. What I mean with raw PyTeal, you have the chance or the option to do ABI, which is application binary interface. I mean, you can create a complete different approach for creating application with using a JSON artifact that allows to know which is the method that I will call, which is the arguments, and it's completely different way to create. You have to use a router for creating this kind of a smart contract. We didn't do that here because this is like the first step. But we can migrate the smart contract and create an ABI version. But also, if you want to go further, you can create a same smart contract with Beaker. Beaker is an abstraction, a new level where you don't have to worry about making the deployment here, maybe having some accounts, maybe in the compiling, those things that we're making, Beaker can manage with just one function, which is very, very simple. Even the opt-in can be made with Beaker with just one function that is already defined. So maybe in the next sessions, you will be learning about Beaker. So you can maybe later come back and recreate the whole application with Beaker. Okay, this is just raw PyTeal. This is the first step on your learning path for algorithm. But you can go with API, you can go with Beaker, you can go any further or deeper, whatever you want. Okay, we can maybe after this session cover the same application with API maybe or Beaker, or maybe you will have another different example, but it's just for you have the clarity of the whole option we have for creating a smart contracts application over here. This is list of resources, so you can enter every one of them. And for the last, there's this slide. This is kind of the QR, and you will have the link to enter this slide and create and have all the resources that you need. So that's it, folks. Thank you so much for your time. Congratulations for finishing this session, and happy coding. Have a good day. See you soon. Bye-bye.
All right. I think I'm going to bring up these slides one more time, or the QR code for the slide one more time, just so that you all can scan it and get to that point, so that if you have to replay the slides, you can. So excuse me while I fast forward a little bit there. Hold on one second.
Okay, here we are. Welcome everybody to this new session.
Let's see if I can get to that spot. Let me just try to do it. Sorry. Let's see if it will come. All right. So if you need the slides or the access to the slides, here is the scanner code or the QR code for you to scan so that you can have access to it. If you do have any questions, the best place to reach out would be to Everett or the Algorand team on the Discord. You can go to Discord. There is a channel that's specifically for greenhouse hacks where we've been communicating. But if you do want any type of assistance or mentorship, I would suggest either dropping a line in that channel or in the general channel on the Algorand Discord, and they'll be able to help you there. With that, that will be the completion of this session. Tomorrow, we are going to have a preview of the challenges and go over just different ways to get started. So if you want a little bit of insight to what challenges will be happening during this hackathon, you can join us tomorrow at the very same time. We'll have Joe from the foundation here, and he'll be giving a high-level overview of the different type of challenges that will be happening during this hackathon. Other than that, I wish you all a great day. I'll see you all tomorrow. And there's just a couple more days till the start of this hackathon, so feel free to try to do any of the lessons, do the additional homework if you want to, and reach out for mentorship. All right, y'all. I'll see you in a bit. See you tomorrow. Have a great day. Bye.